Machine learning is all about calculus, algebra, algorithms, probability, and statistics. But wait, there are a few very important concepts in machine learning you need to know that doesn't require so much knowledge of the topics mentioned earlier. In this video, I will be breaking down 6 must-know concepts every entry and advanced machine learning practitioner needs to know. What is machine learning? Machine learning is all about making machines get better at certain tasks by learning from data, instead of having to explicitly code rules and if statements. The number one machine learning concept you need to know is the concept of overfitting and underfitting. Just like humans can cram simple solutions to math problems, but if the problem is tweaked, then it becomes difficult to get the right answer. Models can act this way, and this is called overfitting. Overfitting is when a model crams the entire dataset it is trained with. In this case, the model tends to predict correctly given data instances found in the dataset it was trained with. If a new data instance is not exactly in the dataset but related to the underlying problem, then it will be predicted wrongly. For example, let's say we have a dataset identifying emails that should be marked as spam. If this dataset is used to train a model and the model overfits, then the model can only predict a spam message if the message can be found in the dataset. Every other spam message given to the model will be predicted wrongly as long as it cannot be found in the dataset. What is underfitting? Underfitting is when the model is unable to learn the underlying pattern in the data. Usually, because the data is not large enough, the data has few important attributes and features that correlate. It can also be because the model used is too simple. Next, we have generalization and regularization. Generalization refers to the model's ability to accurately predict on new data instances not in the training dataset. Regularization is a technique used to improve the model's ability to generalize. It prevents the model from overfitting by modifying and adding penalties to the cost function or reducing the model parameters. Precision and recall are fundamental concepts in machine learning which is often misunderstood. Precision is concerned with the model's accuracy in predicting positive instances. Imagine we have a model that predicts 25 email messages as spam, but only 21 of those messages predicted were spam emails. In this case, we can calculate the model's precision to be 84%. By taking the number of true positives and dividing it by the number of true positives plus false positives, we get the precision. In a nutshell, precision answers the question of how many instances predicted by the model were truly positive, given the number of instances the model has already predicted to be positive. Recall, also known as the degree of sensitivity, refers to the model's overall ability to correctly predict positive instances. Recall answers the question, how many correct positive instances was the model able to predict, given that we know the overall positive instances in the test dataset. From our previous example, we assume our dataset contains 30 positive instances of spam emails, and our model predicted correctly 21 spam emails. Using the formula true positive divided by true positive plus false negative, we get our recall value to be 70%. The recall percentage is vital in critical systems, where it is devastating for the model to predict an instance as false when it is true. For example, a model used in a fire alarm to identify a fire outbreak. In this case, we cannot afford for our model to predict an instance as not being a fire outbreak when in fact it is a massive explosion. Systems like this can trade high recalls for lower precision because predicting a fire outbreak, even when it is not, can be tolerated.